Good afternoon, this is Schweitzer, and let's see what we're going to do with titration. So this is the last video was what happens when you mix an acid and a base, and that is ultimately what we are looking to, once again, just see what we're going to do with this. You know, what can we achieve with this? So one of the biggest things we want to do with a titration, that's just the laboratory procedure of mixing acids and bases, and other things too, not just acids and bases. But essentially, we can determine the number of moles of an unknown substance. Okay, well that's pretty nice, because if we can tell, essentially from this, there's a few things we can get from. We can get a concentration of an unknown. And that is something we use a lot, you know, as far as everything from, really everything, like lead and water, for example, or the amount of concentration of, you know, anything that we deal with in the supermarket or anything else. You can test something to find unknown concentrations. We're always testing for concentrations. All right, another thing we can do with this thing using moles is grams per mole, and that is the molar mass. Now, one nice thing about that is it can come close to, not exactly perfect, but it can come close to identifying the substance. This is what we will be concentrating on for our particular class, but you could use the moles here, or you can use the moles in molarity equals moles per liter here or here, and other things too, but these are the two big ones. And we will be looking more at this one in this particular video. Alright, so first things first, how does it work? Well, we have a large container that would be dealing with what's called a burette. And it's just a fancy tube that's got lines on it. You fill it up and you can turn a stop valve here, and it will allow you to dispense some things together. In the bottom here, we need some way to know when we reach what we've been referring to as equivalence. So in this particular reaction, we have NaOH and HCl. So NaOH plus HCl will produce NaCl plus H2O. Now again, down below here, those are all clear colorless solutions. And when we add them together, we've had plenty of beakers here where we're literally just taking H pluses from one beaker and hydroxides from another beaker, and we've been attempting to try and just match them up to form waters. And we want to match the two up so we can see that they're equal. Okay. And either way, so we've had a few different experiences with this, but how do we know when we dump this in how much we've added? We want to add equal amount of moles of, in this case, of our burette, which is NaOH. And I typically put the known substance up top and the unknown substance on the bottom. It doesn't have to be that way, but it's how I do it. So in this situation, we have a concentration of an unknown acid, just 25 milliliters of it. Okay, and we're going to start adding our stuff in. How do we know when we've added to equivalence? Which, again, we've had a couple examples of. Well, there's two ways. One, you can use a pH meter. The pH meter would read a pH, and I'm going to show what the pH meter would look like here. And then here, or you can use an indicator. Okay, now an indicator is a chemical, okay, that is sensitive, okay, to changes in pH. So the most common one that we would use would be called phenolphthalein. And phenolphthalein happens to be, in acids, it's clear, but in bases, it's pink. Okay? So we're going to start adding in, see what happens. Okay? So let's forward one slide and see, okay, we've now added it a little bit. You'll notice it's still clear. I mean, we would literally titrate to our first thought of pink, first sight of pink, when it stays pink. So now we're moving along here. Again, phenolphthalein is still clear. Okay. And we're added, looks like you see it dropping down. Alright. Again, our indicators, phenolphthalein, still going clear. That 22 milliliters. Haven't had a whole lot of change here. As we're adding our known and our unknown together, neutralization's occurring. We still have, looks like, plenty of acid left. Alright, next slide, and all of a sudden we have a large change that occurs here. And my other indicator, the phenolphthalein, okay, turned pink. Okay, and of course there's a little technique involved here, but looks like we added, this happened, and a huge spike on our pH meter. The way we get our equivalence is by dropping this down here, right here, and it would be 25. That's the volume of the known that required to equalize the moles. So that's the equivalence point right there. Okay, so let's calculate this out, see how this works. Now we typically use a little chart like this called the known-unknown table. Kids like it a lot, but it's just a table, it's not a replacement for work. We have molarity, moles, and liters. My known was 0.1, I believe. Let's go back and check just to make sure. You'll see it. 1 molar, okay. And let's go ahead and put that in here. So that's what's down here. We had 25 milliliters. That's my knowns in here, my unknowns here. So my known is going to be 0.1. Sometimes I like to put NaOH above it, or even just base. And then below is my acid, which is going to be unknown. I don't know what this is. And my volume I had was 25 milliliters, 0.025 liters. Alright, now what happened here is I dispensed some. And what I typically would do is a start and end. So I want to know how much I dispensed. I don't really give too much of a hoot about how much is left in there. I just want to know how much I dropped in. And this is going to be 0 and then 25, which gives me a change of 25. And in this case, the pH meter also shows 25 right here. But typically, this is the way we would get it, just by reading it off of the chart right there. Alright, so this guy here is 0.025. And there you go. So now I'm using this formula, molarity equals moles per liter. And I'm going to use it to solve out my pieces. This is equal here. So you can see if I have 2 of the 3, I can find the third one. Here we go. This is missing. So molarity times liters equals moles. 0.1 times, it's 1. 1 molar times 0.025 equals 0.025. Okay. And this is 0.025, which means this guy also is 1 molar. 0.1 is 1 molar. Alright, so with that being said, note that we have this, we know our moles are equal, and if our volumes are also equal, then our molarities are equal. If your moles are equal, which they are at equivalence, and if your volumes are equal, then this is equal, which is what it turned out to be. Alright, so that's just an example of a titration. We'll be showing an example in class, or this might be an example eventually you'll see on lab as well. Alright, so let's sketch these beakers out here. I mean, again, we got this little titration here. What's it look like at the 0.12.5, and then we have 25, and even one farther, 28. Okay, so in this case, this is the 0. Now, at the 25, we call the equivalence. And this would be that I've added enough hydroxides to completely match my H pluses. So I got 1, 2, 3, 4. So that means I didn't know it at the time, but I had at that point added 4 hydroxides. And that's going to form 4 water molecules. And there'd be 4 anions, which is the X. And let's draw them like that. Okay, so let's do the X's. Okay, and then halfway would be at 12.5, which means I add 2 of my hydroxides. So I'd have 2 waters. And then I knocked out 2 of those, so there's 2X, there's still 4 X's. 1, 2, 3, 4, but I still have 2 H's left over. H plus and H plus. And notice that I now have half of my stuff, original stuff is gone. So now, of my original acid, I have half of it left. Okay, and what's happening here? Well, I'm not going to show the water anymore, but I have X negative, X negative, X negative, and X negative. That would be typically how we would show it. The whole thing's full of water. But I continue to add more hydroxides in. Well, there's nothing left for them to react with after 25 milliliters. So we would just show we have a hydroxide ion hanging out here, extra. And therefore this thing gets extremely basic. Alright, we'll stop there for today. Just one little example. Thank you.